Hello guys, so in this video we're looking on a variable separable method example 6. Now straight away we'll just go to the solution now that we are conversant with all these steps. Now we are saying separate the x's together and the y's together. Now for this case I'll multiply here. I'll divide here by 1 plus y squared. Again I'll divide this other side by 1 plus y squared. Now for this case, as you can see, this cancels this, and for this side we'll be having this y dy upon 1 plus we'll be having 1 plus y squared. I'll be first dx. It should equal x divided by x squared minus 4. Now for me to get rid of this dx, I'll multiply that by dx to this side, multiply this by dx to this side. Now we are seeing this cancels, we are remaining with y dy should equal divided by 1 plus y squared should equal x divided by x squared minus 4 dx. Now once we are having these, we should take the integral of both sides. Now we are saying the integral to this side and the integral to this side. Now before we continue, let me direct you to my calculus playlist, calculus 2 playlist. We are saying go check the techniques of integration that we are using. There are so many techniques of integration. For this case, we'll be using u substitution. Now I'll be saying let my u, let's say let my u equal 1 plus y squared. Now my du should equal 2y dx. Now arranging from this side, because we have a dy here, I'll say this is with respect to dy, so it should be dy, not dx. So keep in mind when differentiating with respect to dy. Now I'll get my dy alone as du upon 2y. Now substituting our information back to the integral, we are saying substituting this back to the integral, we are saying it's the integral of y divided by u multiplied by what's my dy? It's du upon 2y. Now as you can see, this y cancels with this y. Now I'll remain with the integral of 1 over u du. Now taking this integral, we are saying this is simply just the ln of y. Okay, the ln of u, sorry. Now for this case, we are not including the concept of integration. Now we'll include it to the right hand side. So we are saying it's the ln of the absolute value of 1 plus y squared. Now having this in mind, let's say this is our equation 1. Now let's go and integrate again this other part. Now we are saying the integral. Now we're saying the integral of x divided by x squared minus 4 dx. Now for this case again, similar method applies. We're saying this is u substitution. Okay, so go check my playlist on u substitution. I've clearly explained that. Now I'm saying let my u equal x squared minus 4. So absolutely my du will equal to 2x, and then I'll say I'm respecting it to dx should be dx. Now my dx alone should equal du upon 2x. Now having that, let's substitute that inside the integral. We're saying it's the integral of x divided by x squared minus 4. Multiply that by du upon 2x. X goes with this x. We're remaining with the integral of 1 upon u multiplied by du should equal the ln of the absolute value, which is what of u plus a constant c. Okay, now we are saying it's the ln of the absolute value, which is x squared minus 4 should plus a constant c should equal, remember our first equation, it's ln of okay, sorry, we have messed a bit. Now we are having a half at this point. As you can see, we are having a half at this point. There's 1, so we have a half at this point. Now we should get the ln as to be a half. Okay, so we should get the ln, so this is multiplied by a half. Okay, and again similar case applies to this. Now we are having there's a small a half at this point, get it outside the integral. Now we'll be having again a ln of a half. Okay, so be keen to that. Now I'm saying ln of a half should equal a half the ln of 1 plus y squared. Okay, now once we're having this, we'll just rearrange this to be so a half ln of 1 plus y squared should equal a half ln of x squared minus 4 plus a constant of integration c. Now, from this point, multiply by 2 through. So multiplying by 2 through, I'll get the ln of 1 plus y squared should equal ln of x squared minus 4 plus a constant of integration. Taking the exponential of both sides, for us to get the rid of ln, we are saying this goes to 1. So I'm saying 1 plus y squared should equal e to the ln of x squared minus 4, plus a constant c. Now, these we are saying it's 1 plus y squared equal e to the ln of x squared minus 4, which I can multiply that because it's addition. We are saying multiply that by e raised to c. Now, let me explain something at this point. Now we're saying ln, so there's a multiplication here because of properties of logarithm. If we're multiplying same bases, they have the same power we are adding. Now, so for this case, this is just a positive constant. Now, we'll assume it to go to just a positive constant c. Okay, now I'm saying 1 plus y squared should equal e to the ln of x squared minus 4, and then I'll just multiply that by a constant c. Okay, now for this case, I'll simplify that to be c e to the ln of x squared minus 4. Now for this case, what is the e to the ln? Is simply that function above. Now I'm saying it's c multiplied by x squared minus 4 as my answer. Now my general solution is will be 1 plus y squared should equal c to the multiplied by x squared minus 4. Okay, once we are having this, we should get this is the implicit form. Now we should get the explicit form where now we are finding only one value of y. So I should get for me to get y squared, I should take this to this other side. So I'm saying it's c multiplied by x squared minus 4, and then I'll subtract 1 to that point. Now for me to get my y, I should get the square root of both sides. So I'll say positive or minus the square root of all these. So I'm saying the square root of x squared minus 4 minus 1. So this is our general form, general solution. Okay, now please like, share, and subscribe to my channel. Thank you for watching. Have a lovely day, and keep learning.